Hello all, this is the Balancing Chemical Reactions Lab, the second video. After you have mixed the two solutions, it takes about 10 minutes before it settles to look like that, where you can clearly see the difference between the powder at the bottom and the supernatant at the top. While that's waiting, what I suggest that you do is to work on the calculations. So let's look at the lab sheet first. This part, these values here, come directly from the previous page. So the 2, the 4, the 6, the 8, those come directly from here. Okay, so the orange column here and the blue column here directly correlate to the columns here. This is just a copy job that you need to do here. Here, you'll need to make calculations. This is where you measure that yellow powder that's at the bottom with the ruler, and we'll talk about this calculation last. Your analyses and conclusions of your lab at the bottom ask you to calculate the number of moles of lead nitrate and potassium iodide, not sodium iodide, added to each test tube. So that corresponds to this area here and this area. Let's talk about how to make those calculations. So what you're going to do is you're going to take the number that is in the tube number for lead iodide, in this case it's 2.0, and that will be plugged into this equation right here. So you'll put 2.0 milliliters here. Now this is basically a root D conversion using molarity that I told you we wouldn't use on a test for quite some time, but we are going to use it in lab. So you'll put 2.0 milliliters, but that measurement is in milliliters, so we need to convert it to liters, and then we're going to multiply by molarity. 0.5 with that funny capital M is the same as 0.5 moles of lead per liter. Again, that first amount corresponds to the amount added to the test tube. The second, it says convert to moles, but you're actually converting to milliliters. And then the last calculation is where you're converting to molarity. You're going to repeat this for the PB and the KI test tubes. So you're going to do this for 2, whatever value you get there, you'll put in right here in this blank. Then you'll do it for 4, 6, all the way down. From there, you'll do the same thing over here for the potassium iodide, except you'll put 16 in. So here, you'll put in 16. You'll do all the math. Some changes though. This here should say KI. This on the end should say KI. But everything else will be the same. So you're just changing your X each time. And so all in all, you'll have 10 different calculations. Once you're done with those calculations, you then should have enough time that you're ready to measure with a ruler the height of your supernatant. So you'll just measure with a ruler, and I actually have a protractor at each lab station that has a ruler attachment that you can use to measure that. Now, part B, after you've measured the amounts, asks you to remove a drop of the supernatant, 2 drops actually, and put 1 on a spot plate. We're not using a spot plate, we're using a reaction surface, which pretty much is just an overhead transparency. Nothing too high tech there. You can see that I have 2 drops for each test tube. So there's 1 here and here for test tube 1, here and here for test tube 2, and so on. Be absolutely certain that you use a new, clean, disposable pipette for each time in each new test tube, or you can mess things up. To one side, we're going to add lead nitrate. To the other side, we're going to add potassium iodide. Let's actually do that now. So if I add 1 drop of lead nitrate, we're going to see what happens. And if I add 1 drop of potassium iodide, we see what happens. Now in this case, the reaction is pretty obvious, but if you couldn't see it because it was pretty faint, you actually could slide the paper out and it actually is a little bit more visible, especially if it gets cloudy instead of turns yellow. So on your lab sheet, we're now looking at the pink area, well actually above the pink area, where it says test tube 1 precipitate by PbNO32, you would write yes, because we can clearly see that the precipitate formed, it got cloudy. By substance added Ki, that should be Ki there, so make that change, that should be no. The reagent present in excess. This is the part that you'll have to think about after the lab, but pretty much it works out to be whatever you add it's the opposite thing that's in excess, because the drop, the supernatant, had to react with whatever you added. In the case of Ki, it was exactly the same substance. The excess substance was Ki. So when you added more Ki, nothing happened. But in this case, the excess substance was Ki, and so when you add lead nitrate, you got a precipitate. You will notice that where those dots changes along the process of doing the lab. So make sure that you clearly write yes and no here. Figure out the other ones. And then when you get home, think carefully about the reagent present in excess. Again, the reagent present in excess is going to be not the one that makes the precipitate. So if it says yes here, then the no here, this will be the reagent present in excess. If you have two no's, that means that you had exactly the same amount. There was no limiting reagent, and therefore there was nothing in excess. For the last part of the calculation, and this actually is for the inside of your lab. So when you're working on the lab, the calculations that I just told you will continue here. You'll need to answer this question here. Here they want two separate bar graphs. This one is going to be, it says one graph should show the height of the lead iodide. So that information will come from this measure with the ruler part. And then the second graph, the one on the opposite page, it says should show the maximum theoretical number of moles. So you're going to put theoretical number of moles and your test tubes along the bottom, whereas this one is going to be the height in centimeters and the test tube number across the bottom. When you do this theoretical yield, you got to get those numbers from there, and that's where this part of the calculation process occurs. So we're going to go look at the other board to discuss how to do that. You are going to take the moles of PbNO3 that you found here. You haven't found it yet, but when you find it, that number that goes here will go directly there in the board. You'll calculate, using the mole ratio from the equation on the front side of the sheet, the amount of PbI that should be formed theoretically. Then you will do the same thing for the corresponding 16 milliliters of Ki. So that, I'm sorry, 16 milliliters, you'll have that mole number there. So whatever that mole number is, that will go here. You'll do the same calculation. Notice that the mole ratio is different because of the equation. Once you get those two numbers there and there, you need to compare those two numbers. And the two numbers, you need to pick the one that is your theoretical yield is going to be your limiting based on your limiting reactant. So whichever one gives you the lowest number of moles is the one that you would write on the table. So for test tube number 2, you would have found this mole amount earlier. You will plug that mole amount in there, calculate. Then you will take the 14 grams, plug that number in the second equation with Ki, calculate, and whichever number is less, that is the amount that will go in the table by test tube 2. So you repeat this process, and this yellow area here is actually what becomes your y-axis on the second chart. Don't forget to complete the experiment in full. There are questions at the bottom about how your two graphs compare. There are questions that ask you to write the complete ionic equation. We've talked about that in 11.3. A lot of you are very good at that. And again, you have the reference equation on the front side of the main sheet. It actually tells you the original equation. Don't forget to come up with, develop a hypothesis, and design an experiment. But today we've talked about all of the calculations. So pretty much what you're going to do is you combine your two chemicals together. You're going to get a cloudy yellow substance that will eventually settle out. While you're waiting for it to settle, you'll do the calculations for the table using these measurement amounts to find your number of moles. You fill that in on the table. After you've done that, you'll come over, you'll add 1 drop from each test tube with a clean pipette each time. Then you'll add to one entire row lead nitrate, to the other entire row potassium iodide, and then you'll make a note on your data table which one caused the precipitate. The precipitate tells you which substance is in excess. So again, on your data table, you would fill in yes or no in this case, and then that will tell you your reagent in excess. Once you go home, you can continue the calculations to the second calculation, and for that you'll use the number here, plug into the first equation to calculate the number of moles. You'll take the second number here from this number of moles, plug into the equation, and then compare those two numbers to which one is the smallest, and that will tell you your theoretical yield. That number there is what needs to be written there, with the smallest of the two numbers. You'll complete that with each mole amount, making sure to attach those calculations to your lab so I can give you full credit. Then you'll answer, look at the test tube with the greatest amount of precipitate. You're going to calculate the mole ratio, and then you're going to make two bar graphs. The first one with the height of the substance in centimeters with each test tube number, and the second one with the theoretical number of moles that you would make with the test tube number. Don't forget to answer the bottom of the questions at the bottom of the page and on reverse. I think that's about it. For those of you who didn't get a good shot of the boards, I'm going to zoom in on each one separately so you have a couple seconds to copy that down. Push pause. I'm trying to move so that the glare of the light isn't in the way. So you have the first set of calculations, and then here's the second set of calculations. This set helps to calculate the number of moles. This set helps to calculate the theoretical yield. I know the video is a little long, but I wanted to make sure that I covered everything thoroughly. Take care and see you in class next time. Bye-bye.